Here we go. Acidity of an alcohol. So if you look at it, ladies and gentlemen, this is the alcohol. This is the conjugate base that is formed. You need to know the English word. It's called ethoxide. Very easy. Water is the control. So the conjugate base is called hydroxide. Okay. So the green color is the control, right? Compared to the green. So here we go. In ethanol, what happened is the negative charge in the ethoxide ion. I want to bring the attention to you is when we want to discuss acidity concept, you don't look at the molecule, you look at the conjugate base. Everyone understand? It's always phrased this way. Please take note, keywords to get full marks. This is the way to discuss acidity of organic compounds. It's talking about the conjugate base. So ethoxide ion is the negative charge over there, right? Which also means the lone pair is intensified. By what? By what we call the electron donating R group, the ethyl group. Where is it? Here it is. Can you see? This is ethyl group. Very easy. It donate. Now, do you realize the lone pair here is super big already? I.e., the negative charge has been intensified. Now, if this is very big, then what happened? It will become a stronger base as compared to the lone pair on here, which is smaller, everyone. Because what happened is, if that's the case, then the H plus that you threw out just now, you tend to go and deprotonate it, or rather go and protonate it back. Can you see? Make sense? You want to grab it back through dative again. Can you see? Which means this will want to reverse back. Make sense? Reverse back to become the molecule. Which means it doesn't want to dissociate that more. Make sense or not? So the dissociation, not Ka, but the dissociation, the alpha, will decrease. Make sense? Or in English terms, we say that the ethoxide ion, all right, is less stable than the hydroxide ion. Okay, so you need the word called stability of the ion, i.e. the conjugate base. Next up is the effect of substituent on acidity of alcohol. Still alcohol, but hey, what if the alcohol got substituent on the carbon, right? So once again, if you look at it, right? So given 3 molecules, this is the control. All right, this is the control. Okay, so let's take a look at 2 different colors. All right, so electron withdrawing groups versus the presence of electron donating groups. Okay, so withdrawing groups, you will be looking at these substituents. All these technically don't memorize because it's in the data booklet. Okay, remember when we learn arenes, we will be looking at all these already. It's in the data booklet, so you can just apply. Last time we have to memorize, now you all don't have to, the new syllabus. Okay, before I continue the discussion, you must appreciate something, is that remember, it's about looking at the conjugate base, the anion, not looking at the molecule. So in my mind, when I explain, look at my approach, I am not looking at this. Instead, I am looking at this. Are you with me? Okay, that is the approach when you're thinking and trying to write out your keywords. Okay, so here we go. If you have electron withdrawing group like halogens, all right? Fluorine, halogen. What it does is that it will draw electron towards itself and away from the oxygen. Make sense? So if I use lone pair to look at it, I hope you agree with me. If this original, this control is this big, then this one is tiny. Okay? Very easy one. If that's the case, it also means that it stabilizes the alkoxide ion, the one that I just drew on the left. Make sense? It will have lost lone pair, less intensified negative charge. It will have less tendency to take back H+. Yes. Which means the H+ like to go to the right rather than take back to the left. Yes. So it promotes ionization process, the dissociation at H+, right? And increase the acidic character. Easy. Okay? And the opposite must be true. Here we go. CH3 is electron donating. Okay? So what happened to the lone pair? Super big. Okay? Easy? Like that, Joshua get it one. Okay. All right. So once again, So a lot of lone pair, very intensified negative charge. So you want to reduce the intensity, right? The negative. So you take back H plus to kind of balance out, right? So you want, you then reverse to the left, right? To the molecule. So it destabilizes once again the alkoxide ion and reduce the ionization process. Okay, H plus don't want to come out that much anymore. So reduce the acidic character. Okay, which is clearly shown using the value, right? So you look at it, this is a control. So pKa, when it's bigger, it means Ka is smaller. So this is least acidic among the three, the two extreme end. This one, the most acidic among the three, based on the pKa values, right? Remember, pKa is inverse to Ka, whereas Ka refers to the strength of an acid. All this we discussed in the previous topic called acid-base equilibrium.
If you would like to catch my latest videos, click on subscribe button right now. And click on the bell if you want to receive instant notifications once I've uploaded my latest video. If you would like to join my live chemistry classes and revision workshops, go on to winnerseducation.com and find out how you can score distinction for chemistry on a consistent basis, either in our center or online via Zoom. If you want to check out my online school, go on to passwithdistinction.teachable.com. You'll be able to learn chemistry concepts at your own pace and anywhere in the world, topic by topic. This is Sean Chua from Winners Education, to your distinction in chemistry.